All yours.
Okay. Thanks for having me. My name's Gerber. I work at Apptio. Jason here from Apptio is looking for senior developers, so please give him a chat if you get a chance. We're doing really cool stuff here at Apptio. A lot of big data manipulation, a lot of analytics, and some workflow. And my background. I've done a couple startups prior to Apptio. One of them was iConclude, where we built a workflow system. I started out, my first experience with workflow was building a testing framework. It was actually a next step, but it was a pretty interesting framework that used some pretty advanced data generation techniques. And I kind of got a flavor for some patterns that I was able to apply into the iConclude system. iConclude was a service orchestration product. It was acquired by Opsware and then HP. It's now HP Operations Orchestration in the product. And so I kind of saw some repeating patterns that I wanted to share with you. And at Apptio, we're in our data processing capability. We also use some workflow, but in a kind of a different way. And I wanted to compare and contrast sort of styles of workflow. And honestly, this talk was put together at kind of a last minute, so there's a lot of room for discussion in the talk. So let's definitely make it interactive. You guys have, I'm sure you have experience with workflow as well, and we'd love to hear your thoughts on how they contrast compared to mine. So what is workflow? I Googled it, and this is what came up. Sequence of industrial, administrative, or other processes through which a piece of work passes from initiation to completion. That's sufficiently high level to define almost anything. But I think there's a lot of different applications of workflow, and people often ask me, like, what kind of workflow should I use for my problem? And I typically break it down into a couple different concepts. This is not a comprehensive type of list of workflow, but I think there's a lot of, I generally see these patterns. So what I call scripting is workflow that's really kind of like imperative programming, some decision tree. It's going to go through some steps. It's going to do this, and then do this, and then do this, and this, do that, and so on. And this is really great for capturing really complex orchestrations where you're going to need a lot of constructs like loops and conditionals to kind of go and orchestrate several different systems to get something done. And this is the kind of workflow we had at iConclude for deploying services or coordinating that a ticket was synchronized with a job that was happening in an IT system. So that's what scripting is. Finite state machines, typically they're you predefine a set of states, and there's a lot of rigor around how you can transition from one state to another, and you're really trying to capture the whole life cycle of the workflow within the workflow. And this is good for, well, or capturing the life cycle of a thing, like a service or a loan that you're going to process. Business processing is usually done in this kind of style of workflow. But I find that it's complex, or it becomes overly complex if you have a lot of states. So these systems generally work best when there are fewer states, and there's a few transitions and simple logic to decide how you do transition between those. Typically, these also very long-running workflows, whereas the scripting ones are short-lived. You're going to invoke them, they're going to do something, and they're going to complete. And because they're long-living, they can go for months or years even, and you really want to make sure you understand how you're going to upgrade those over time. You probably need to upgrade them as you have new versions of the software or the systems are integrating with them have upgrades. If this, then that. It's kind of a new hot thing now. These are really short little snippets of logic that really, based on some condition, you're going to trigger some action. The actions are pretty simple. There's websites, there's actually an IFTTT website you go to and build little scripts that kind of, when you get an email, send me a tweet or something like that. And so they're really good for reacting to a set of known events, synchronizing two systems, just to keep them in state, and simple logic. And you really want to think about the richness of the expressions you're going to support when you build those systems. You want to have it really flexible and easy to use, but simple enough that someone can write it, keep the content of the workflow rather small. And you could even link this with another kind of workflow if there's complex events. You can link to a scripting workflow system in the that kind of expression to invoke the complexity and keep that part simple. And then there's stream processing where you have large data that you want to go through some transformation like an ELT system or a lot of big data processing you see around cascading and MapReduce, other MapReduce systems. I'll talk about that a little later. But these systems are where these other systems are sort of executed incrementally. Data processing is like a flow of data that's it's breaking down your data into tuples and they're flowing through some flow. So whereas one step would complete before the next step would initiate in a scripting system, the data processing, all the data is kind of executing synchronously. In parallel across all those steps. So I think when you talk about these systems, obviously it's the distribution model you want to support, whether it's Hadoop or some other MapReduce type system. You want to be able to control all these jobs so you can scale them up, scale them down. And debugging can be a challenge, so I think you also want to have a way to run them in a more isolated scenario to understand where your program is having a problem. That can be a challenge in a big MapReduce job. So from here, I kind of wanted to dive into the IConclude, what we did at IConclude and some of the patterns we discovered there. At IConclude, we were going after IT problem resolution. If there's some monitoring system that detects some alert, and you want to attach some automation to that alert to go and triage the problem and diagnose it to a greater degree, so you can annotate a ticket with that information, or you create a ticket, annotate with that information, and possibly even resolve the problem. But even just triaging it was kind of the main goal. So in IT, there's a lot of, the thesis was you have a lot of tribal knowledge, and you wanted to enable kind of less technical people to execute a lot of that knowledge from the kind of more experienced guys. And there's also inconsistent results, like no two people would solve the same problem the same way. So you want to have more consistency around that. So that was kind of the space we were going after. And we found that just automating the ticket was as important as letting someone interactively execute the workflow, because then they could get more knowledge themselves. They could understand at a greater level of detail what was going on. And when you're talking about interactive execution, you have to kind of support the ability to get receive input from the user during the workflow execution. So workflow can react to the user selecting some option or some credential. So content and authoring key to success, you need a lot of content to solve problems in IT. By content, I mean workflows. So we had to have a really rich system for creating these things and storing them and understanding who authored them and versioning them. So content was really critical, how we manage that in our workflow system. Obviously, creating the content is a barrier to having content, so you want to have a really easy to use visual tool for creating the workflows. This is a common pattern. When you look at workflow tools, they all have some visual designer. What's it called? JBPMN. Netbeans has a pretty slick designer as well. So yeah, we went after the scripting style of workflow because we were basically orchestrating a bunch of services to solve some IT problem.
What did you say about Netbeans? They have.
Yeah, JBPMN, Java Business Process Modeling Notation, I think. It's their visual way of describing the workflow. And they have a drag and drop experience for creating those inside the Netbeans IDE. There's also the JBoss, JBPL system. I don't know if they have a visual designer, they probably do, but they have their own language or their own way of representing the business process. I think they use JBPL, Java Business Process Execution Language from IBM. IBM's an XML schema for describing workflow.
Excuse me.
Yes.
So I was just wondering, I don't know where in your grid it would fall, but just basically doing people-based, role-based queues as a form of workflow where there's actually no, other than the system facilitating queues and managing roles, there isn't really any decision-making that's occurring with this.
Can you give an example?
Well, the travel industry has done that for making reservations and stuff like that for
Yeah,
decades.
like you have a queue of jobs and you want to know which jobs are yours, and so you have like sort of an inbox, a list of jobs, and you're gonna go and execute those.
And the inbox might be shallow in
Yeah.
the sense of fronting a group box.
Right, yeah.
But where basically it's, the rules are relatively small and they're not automatable.
As in terms of where the job's gonna go, is that what you're talking about?
In the sense of determining whether or not it can go on to the next position without having a human test it.
Oh, yeah, I mean, that, I probably would use a finite state machine type of workflow, because the states are still predefined, you just don't know which transition to make, right? So you need a human to go and tell you, oh yeah, he needs to go to this state. Typically, that's what I've seen, where there's some life cycle predefined for like a ticket
Right.
or a job, so you know it's gonna be, you know, created, approved, you know, and so on.
But as you said, it's a very small
Yep.
number of steps.
Very small number of steps, and you still probably want to evolve to some rigor around which states you want to allow. You don't want to go to, you know, execute before you approve, right? So typically, I would probably say that you want some sort of finite state machine. So you're really owning, the workflow owns the state, is the way I think about it, versus the external world typically owning the state in like what we were building, I conclude, where the state was like, you know, what was deployed in that server, or you know, how was the machine created, was the VM created, and so on. The state was external, and the workflow was kind of orchestrating it. So yeah, I think of that as FSM, but you know, the whole queuing and triggering execution or managing the workload on top of the workflow engine, I'm not really addressing that in this talk. That's also interesting, and also probably could be, you know, you could talk about how you can process HTTP requests in the context of those kinds of discussions. So I'm really more focusing on the workflow.
You can have a mix of let's say you have some kind of ticketing system, so you have manual steps to say, well, we are going to start working on this issue, but there can also be steps that are automatic. Let's say once it gets deployed, it automatically sees, oh, this issue has been referenced, therefore we transition.
Yeah, and sometimes you can mix the systems, like you could have a scripting system triggered off a transition in a finite state machine, for example. So I don't think of them as mutually exclusive. You don't use one hammer to, whatever the analogy is, to hammer all the nails in. You use a mix of these systems. So, where was I? Okay, so we went with this scripting style. As I said, we identified this content management as really critical. And we wanted to like have a snowball effect, so when someone creates a workflow that does something complicated, like, you know, some complicated command line sequence to create a new, you know, ticket or virtual machine or whatever, you want to be able to reuse those, right? So that you can make it easier as you get more content to create new kinds of workflows. So we really wanted this reuse. We had the notion of atomic operations. You know, there's some basic capabilities like making an HTTP request or executing some of the command line, or even just a script or a piece of Java that you could plug into the system. And so we wanted to have this kind of basic sort of operation interface where the atomic operations could conform to that, and so could workflows, and that way you could have operations that were other workflows and get some sort of recursion capability there. Like I said, content management, the ability to search, the ability to know, because now if you're saying this workflow invokes this other workflow, there's a dependency there, and what happens, you have to know that your workflow is broken if this workflow is broken. So you have to understand the relationships between these workflows, and the content management system needed to support this notion of smart references, so that you could do sort of broad validation of the system to know, is my workflow capability is it healthy or not? Is there some breakage in my workflows I need to fix? And you know, imports, exports, so you could ship you new content, you could share content with other groups that were using the product. Obviously security is important because sometimes there's some credentials stored in workflows. We actually had a credential store system that was sort of separate eventually. So that was really key, this content management thing. And then in the authoring, we wanted a real like drag and wire, we called it, environment where you have this toolbox of operations and workflows and drag them onto the page. I'll show you a screenshot a little later. Embedded scripting, so we knew we couldn't prepackage all the capability in the system, so we had to let you extend it. We chose, obviously we chose Java for this whole thing. I'll talk about why we did that in a little bit, but there was great support even back in 2005 when we were building a product for JavaScript. We used the Rhino engine. So we were able to embed that. Actually embedded Groovy as well, but nobody understood what Groovy was in IT, so that didn't really fly. Really, we wanted Perl. Like at that time, Perl was king, and there was no great solution for Perl execution on the JVM. I found some, but it was pretty sketchy. And it ended up being so different than the regular Perl distributions you had that we kind of dumped it. Okay, so content management, authoring, and then very important, in fact, probably most important, was we really needed a runtime that was able to scale to the volume of workflows we need to execute. Sometimes these alert floods would happen. You had to launch an incredible amount of workflows very quickly to solve a problem. Actually, interestingly, most of the time when that happens, there's some other problem. So the system had to be able to detect that there was a lot of invocations of this event and discover that, oh, actually a router went down or a whole data center went out. So that was kind of an interesting thing. So the runtime had to scale. We also had to support the interactive execution so that you could see the workflow executing, and it could prompt you, and it was really easy to understand and debug. So you could see the state behind the workflow, all the different local variables and so on that it was working with. Logging, incredibly important, because you want to capture the execution history of your workflows and understand which ones are going to be resolving problems with applications versus databases versus some hardware. So the ability to sort of tag or discover interesting aspects about the subject of the workflow as it's executing, or record that with your log in a way that was searchable, so you can do sort of analytics on top of that and understand which are my most expensive types of routers, because so many workflows are running against them if you reboot them. So that capability was really important. So those are kind of the three important things. Java we chose for a number of reasons. When I really think about it, it's because we had expertise in Java, people that do Java. But you have, I think, an amazing amount of just stuff that's written in Java. Like you can cheat so much with open source frameworks and APIs to most. There's usually a Java API to most IT systems, it turns out. That's probably being replaced with web services now, but it was, it was like Java first, then web services back in 2005 when we were working with this stuff. So, we chose it for a lot of reasons, but like I said, the ability to hire, as a startup, the ability to hire people that you can hire, within your network in the first year is probably the king. So we had a lot of expertise there and hiring people. So then we thought about our domain model, like how do we represent workflows? Again, I discovered a lot of these patterns back working on the testing frameworks, and so I just naturally started with the same set of entities I've used before, and it really fit pretty well. So, like I said, we have the notion of an operation, which is like the basic unit of execution. It could be some atomic thing, like like I said, like running a command line, doing a web request, or SSH session or whatever. But it could also be another workflow. So everything you can execute, every unit of execution was wrapped in this operation interface, and operations basically have a bunch of inputs, some parameters that they're going to take. These were typed, so you have different. Maybe it's just a string, or maybe it's something more semantically interesting, like host name. It has some certain format to it, or email address, or it could be even some binary value. So we sort of extensible parameter class called input, and a set of responses, meaning the operation is going to, we kind of broke the output into output, which is data, and response, which is the thing that's going to trigger the next operation. So responses was really an enumeration of, that's not true, you could actually extend it, but 90% of the operations ended up being pass or fail, and implicitly there was a response for error in the system. So basically the contract was, you pass me some inputs, I'm going to execute whatever I'm going to execute, I'm going to throw out some data as output, and I'm going to send a signal as a response. It's either going to be one of the predefined, it's either going to be a failure in the system, meaning the workflow system itself failed, or it's going to be some defined response that you had. most times it was success fail, but for example, for HTTP operations, we had all the error codes listed there. And then, so this was sort of like the way to capture the capability of the system, you know, and then the workflow itself was defined in these flow-related classes. So you had a workflow, which is the flow. Flow has steps, and this was an ordered set of, sorry, it wasn't ordered, it was just a collection of steps, and each step has a transition, you know, it's going to go from somewhere to some other step. And these transitions were linked up to, so the step has a link to the operation. Like when you run this step, it's going to run this operation, and for every response in that operation, there's a transition. So you know, based on the execution, what step it's going to go to next. And then there's this notion of bindings. So bindings was really cool. So when you create a step, you're linking that operation, the step is not valid until you've matched up all the inputs and the responses. So you match the responses up to the transitions, you have to have a binding for every input. And a bindings, that was a polymorphic set of bindings there for doing things like what we call static bindings, meaning you like just assign some value to it, or it could be within the runtime there could be variables, so you could refer to some variables, so you could discover something like discover the name of the host that someone was trying to connect to in one step, and then in a later step you could bind to that value and use it to invoke the next step. So that was pretty powerful. And then most importantly, you could actually have a binding that was a user input, meaning when this flow is executing, you prompt the user for a value, and that could be, there's even several types of that. You could pick lists or formatted text fields or a plethora of stuff, and so the runtime UI can interpret that stuff and display UI that was pretty useful for the user to kind of go and solve the problem. So we had this domain model, and all these guys inherited from some abstract classes, and so they inherited some basic capability around validation, which is really key. So you need to know in a system like this if things are broken or not, because you shouldn't really even deploy that into runtime if it's not going to be able to execute. So what could go wrong? You might not have one of these inputs bound up, so you can't. How can you SSH to a host if you don't know the host name? And so that validation capability was executed at every operation, and then there was a validation engine inside the content repository that could, pass through the entire set of content and give you a summary of all the issues. And those issues were actual objects, validation info objects that were clickable and traceable right back to the workflow or step that was causing the problem. That was really key, because in a big system with, I think when we sold the company, our repository had something like 10,000, 15,000 workflows in it. You can't hunt and peck for problems to fix the system. So the ability to kind of have the smart linking and control validation was really key. So the content repository, when we started, I conclude the Apache Jackrabbit project was kind of, I don't think they were even at 1.0 yet, so I was interested in that and saw some patterns there that I wanted to use to make it easy to just do the serialization workflow, but also this linking capability. But it wasn't at the point where I was comfortable building a product on top of it. It wasn't mature enough. Didn't support really security at all. But I liked a lot of the patterns in there in the JCR, so we kind of modeled out our stuff after that. So we had this, in these CMS systems, there's some notion of a node or hierarchy of nodes that store sort of all your data, and so we had this node class. It had a parent, and then it had sort of a set of attributes. So these are kind of like data members on that node, and then it could also have a reference to, or one or more references to other nodes in the system. And so if you think about this, it's almost like a serialization layer below this. So at the end of the day, our data was stored in XML files. Those were serialized into these node and attribute and reference classes, and then those were serialized into our domain objects, right? So literally the serializer went through that pipeline. And why do we do that? So what we found was there's a lot of the same algorithms you want to process across these objects in a pretty generic way, and it was useful for us to build kind of basic capability against these classes easier than it was to push it against these classes. So we found that we could reuse a lot more kind of across domain object capabilities by writing them against that layer. It also made our serialization extensible, so we didn't have to ever come up with a new XML construct, capture new capability as we added it, new kinds of content as we added it to our domain objects. We just extended the node, just added some more attributes to it. So that was really helpful. But doing things like resolving a reference would just work against this layer, right? We can actually diff two workflows, like you had maybe a newer version of me, and I could show you what was the difference. We could do it at the sort of node layer. It was easier than operating at the higher level. So that was actually really cool. That worked out well. No idea what that means. So like things like our upgraders, as we added a new version of the product, which always auto upgrade previous versions, and all ran against this stuff, and you didn't have to. You could just kind of work at, like I said, you're working at this level. It was sort of the same group of people could build more and more knowledge independent of how the domain model was evolving, and it just made it a lot easier as we went forward.
Quick question.
Yeah.
You were starting from scratch today and having to decide how to persist this kind of stuff, and you were making like a build versus buy decision.
Yeah.
What would you be considering?
No, there's some great stuff out there that does.
But what's not done?
I was just looking at a framework. Well, Spring has some stuff like this, right? For doing annotation-driven serialization. There's a ton of, like, if you just Google for Java annotation and serialization, you'll find a lot. If you look at like what we did,
That's standard Java, isn't
Yeah.
it? 2.6?
yeah, you can use Java serialization for sure. There are issues with that, which you probably would want to consider around performance and so on. We could get into that. But here's what we did. You'll see a lot of very similar things. It was just that there wasn't a lot out there at that time that did it as well as we thought we could. And it was a build versus, I remember we looked at a couple frameworks, don't have them on my mind right now. We looked at a couple, and we kind of compared the level of effort to implement something like this versus early POCs we did with those serialization frameworks and diagnosing performance problems. We actually were using Xstream at one point, and just running into a lot of just memory management issues and performance things. We actually brought that in later as it evolved, because we stayed close to emerging APIs we liked. We were able to swivel some of those things out. But the investment wasn't too bad to build the system, and it kind of gave us some deeper capability to do things like managing these references at a pretty low level, close to the serializer.
But ultimately, you were just persisting XML.
At the end of the day, yeah. But that XML had to be, important. We needed to be able to do things like, you could have a master repository and a slave repository, and do check-ins, check-outs, and diffs across those with versioning. So doing that at a low level was actually an advantage for us.
Okay.
Right?
And it was with a schema, and you had to have.
The schema was very simple. It just captured these elements, node, reference, attribute.
So when we were doing diffing on XML, we actually modified the XML generator to make sure that the attributes came out alphabetically, one per line. Because then it made diffing a piece of cake.
Yeah. And that's actually an important thing. A lot of people say, well, why don't you just use CVS or some other SEM? And the semantic capability is really important when you're doing diffing, right? Things like ordering, that's not always easy to do. Like if you can make it alpha, that works.
Right.
But if semantically it means something different when you move something around, it can be really hard. So it's a pretty subtle thing, but I think there's actually some good reasons for having something pretty close to the wire when you do this.
We were
kind of stuff.
experiencing, before we did this, we were experiencing merge conflicts when the only thing that had changed was
Yeah.
the order of the attributes in XML.
Yeah, Xstream.
Because they're not specified.
Xstream was actually a problem for us for that. At that time, it was really hard to make it order things.
I thought there was some kind of XML-related standard canonicalization or something that defines, I think it's also used like for doing signing XML documents. So there's probably libraries that will like transform your XML document into like a
Yeah.
Probably one
I
of the
think-
things to do is like sort the attributes alphabetically and
Right.
do a bunch of other things.
And we actually had a fine-grained schema like that. We actually had these classes directly mapped into XML schema. And we just ran into so much churn as we added more capability to this domain model. Every time, we'd have to go and like modify the schema. Actually, originally we had this in a Hibernate, persistent, like with fine-grained objects in Hibernate, and that was hell. Because every time you upgraded, you had to upgrade a database schema. That was awful. So, we thought, hey, we'll just go to XML, and then we had the same problem with the fine-grained schema. And then that's why we really went to this more simple schema. We never changed it after we went to that, because it was expressive enough to capture all of our stuff as a composition of these objects.
So you still had an XML schema, it was still bound to a schema, but you figured out a way to make it simpler and more extensive?
Yep.
Okay.
Yeah, the schema was fixed, and the object model changed on top of it. So, yeah, this is just an example of what our system did. Just with some simple annotations of our domain classes, we were able to write a serializer that went through and persisted this stuff to XML. So this is a flow, saying this has an attribute. It has a reference to the steps, and you'd have two types of reference. One was a contains reference, meaning it would be in the document, the same document, and when it's serialized as this object. Another kind of reference would be this steps have operations, like that's a reference to, if you don't contain the op, right? So the steps refer to an operation. And so that reference was defined as false. Default, you say nothing, and the system would know that it had to resolve that at serialization time to the object it was pointing to. And then this is something like the XML that we generated, where you'd have this flow as these steps. This is a step within the steps collection, and refers to this opt execute. It would just have an ID, which would be resolved by a caching system at runtime. And then that step would have some bindings. So the bindings would describe what kind of binding it was, whether it was static or whatever, and the input that it was pointing to. And so the repository, what it basically looked like was, we sort of had something like a class registry. You could pass in sort of a package or class path or package expression, and we'd go and hunt through those classes for anything that had our attributes in it, and then create the information about those classes and cache them. And then the Java reflection would use that information to deserialize those classes at runtime. And so this repository object that really contained all the workflows at runtime leveraged this serialization system to push and pull data to the XML. And it basically had a directory of workflows that it would maintain for you and manage the persistent back and forth from the in-memory to the XML files. It also had a catalog of all of those IDs of all these workflows. And it was so you could know which workflows refer to these workflows and which sort of a bi-directional catalog between the two. So you could do things like show me what flows use this flow, or what flows does this flow use. Right? So those are really important questions in the content repository. All right, reset all this stuff. So yeah, what did it do? It did the serialization, resolved the references, the document hierarchy it managed, and then yes, it had this validation capability. So it was really important to cache a lot of this data, so you didn't revalidate stuff that didn't change. So we had this notion of like dependencies, and if this didn't change, you don't need to go descend into this tree to revalidate. But so it kind of maintained a smart cache of all the validation issues, and knew when it had to invalidate that. Search was huge, and that's what I was talking about, this index. We use Apptio to index the whole thing. So that content thing, actually when I think back and I conclude, it was probably the biggest investment that we made in terms of our technology. The execution engine was pretty tough, but we really spent a lot of time in this content thing, and it was really the thing that pushed us ahead in the marketplace, is our ability to work with a big set of content that was pretty complex and interrelated. So the authoring environment, that was, had to be slick. At the time, we chose Swing. It was probably the last desktop application I'll ever build. You know, those are the days. At the time, you know, we weren't a SaaS company, we were on-prem deployment. It was pretty easy to build an application in Java. We used JGraph as our visualization framework. So this Swing app would connect to the repository via web service. It was RESTful. It had a pretty comprehensive AAA solution, so we supported, you build your own certs and install them in the client, so we trusted connection to the repository, or you could do challenge-based. It was pretty strong encryption back and forth. AES, whatever, 256, I can't remember. I think yes, sir.
What's AAA?
Oh, authentication, authorization, and audit trail. So security stuff. So this is a screen grab of the current product. Actually, it's very similar to the last time I looked at it. Just went and grabbed it on the website. Apologize for the fuzziness. But basically, this represents everything I talked about. So this is a workflow. There's a bunch of steps in this workflow. Those arrows are transitions, obviously. These little icons here were the responses. So most of them just really had sort of pass, fail. I think everything here does. There was a pretty well-defined set of things that you had to have satisfied for a workflow be valid. It had to have, you know, an entry point, which is indicated by this green outline here. It had to have at least one exit point, which I believe is these guys, yeah. So each one of these is an exit point, and these icons match up to the response icons because these are the responses for the flow. So whereas for an operation, you would codify the responses that you would have, like an HTTP request would have, you know, 200, 400, whatever. The flow is a little more, you code it, you created it by virtue of creating the responses, so the exit points in the flow. So these kind of special steps. It says, when this flow executes, here it's an error, versus here it's a success. And so the validation system could pass through this flow and say if it had a problem where it was. And you would see that down here in this problems tab, enumerate all the issues, and you'd see here indicated in the tree throughout the repository. And that worked really well for us. But it was really visual. You know, the iconography was really important. Yes?
So this is the designer, this
Yeah.
is not the current
Not the
state.
runtime.
So, what I've seen in the past is that since quite often you need to have escape valves on every single spot where there's a human that goes off to a supervisor or something.
Yeah.
You can't model this in here unless you end up with a rat's nest of a model.
Well, typically when that would happen, there was two ways to deal with it. One is the workflow can pause, and you can send somebody else. You can pause the workflow and say, hey, I need to escalate this, and I'll send you a link to my work operation, and you can take it up from where I left off. That was one way. Another way is there was actually a step that would pause it, right? So you get to the current point, and it would say, oh, escalate, right? And then it would respond with a responsive success or
Right.
something.
I guess my point is that each step has a potential escalate option, and it's not modeled on here because it makes the graph too busy.
Yeah, you would get some flows where you have like this fan in to escalate. That would happen, but typically when that does happen, the customer, the best practice we have is the customer try to like dissect why that was, right? That typically is like some process issue, right? And you want to actually get more fine grained and understand, well, how can we triage this more before we escalate this person? So we typically end up like creating more subflows that would go into the detailed areas. There is a capability, I believe it's in the product now, it wasn't there when we sold it, where you could have this exception kind of like just create a step, say, hey, you know what, there's no like transition here, but any step could go here based on some condition. It was always in our roadmap, we never ended up being implemented because, like I said, we would always go back to the customer and say, hey, you know what, how can we really rethink this process and add more fidelity to what you're trying to do? So, yeah, I mean, that is a symptom of this kind of design, for sure. You have these fan ends. But the other point is that you don't have to have just one success, right? You could add this to many places, you know. That was an early problem, we could only let you have one, and you'd have like everybody go to the success at every exit point. We said, why do we have one? Let's let them have multiple exit steps of the same response type, and that was really helpful.
So in practice, would your users actually use this graphical thing to build their workflows, or do I kind of suspect that often what happens is that, like, it's nice to look at, but in reality they need a programmer to like actually assemble the workflows?
That was a key to our success. So our main competitor was a company called RealOps. They were powered by BMC. And that was their approach. They basically had a visual designer, but then you had clicked another tab and you ended up people, right? And the barrier to entry here was like ability to get people to write workflows. So we had to really like be honest with ourselves and make this thing work. And it took a while, but when we got to a certain point where we had enough basic operations that you could really drag and wire stuff. And there was a really rich, I'm not showing it here, there's a really rich step inspector, so you can click on one of these things and expand like a pretty elaborate properties view, or you can have a JavaScript op and you can right there edit the script. So I'm kind of copying out by saying you could still get down there and program if you had to. But for the most part, people were
at this
dragging.
level, it's like if this, then that, so you have like a fixed set of, but you mentioned like some of your tasks will involve scripting.
Yeah. So like I
Probably
said,
at that point you,
then you get into the property editor and start JavaScript. But you're not writing Java, right? And what we really wanted to do was make it so that people that wrote those scripts really focused on building an operation that was useful, so that the next time they need to use it, it's dragging in a step. And then you have to wire up some inputs. You don't see the inputs here, that's also in the property, which is, we wanted to get to the point where we actually show the data here too, we never got there, but in the inputs inspector, you would wire up and say, oh, this host name, prompt the user, make it a host name field with this validation, field level validation. So if you write your scripts in a way that's reasonable like that, we got a lot more reuse, and we actually have customers. There's a big healthcare company I know of that has over 100 people on their flows in this product. Okay, so then the execution environment. How am I doing on time? So, yeah. So the execution environment, like I said, it was really important that we handle the volume. And there was also a lot of code. There was two problems we had. One was you couldn't always guarantee that the action you needed to take was going to be like in the same data center or even the same subnet within that data center. So the challenges getting to the system you need to go and reboot, or do a check disk on, or download a file from, or whatever. So that was one challenge. The other challenge was turns out there was some integrations with some systems that weren't Java, and mostly they were Microsoft systems. And so we wanted a way to write other kinds of code and make it easy. And instead of like building like an embedded system that was going to run it in process, we came up with this notion of a remote action service, which was basically a little agent or a satellite you could deploy, and it would basically have the same operation interface as a web service. So you could steps could invoke remote operations against it. It didn't have the full workflow engine. We wanted to do that, but it just we didn't get time to do it. And it turned out this worked better to have the state of the workflow running in a particular container and a workflow server, and invoke point operations on a remote action service. So you could build as many as you want. You would launch them, deploy them in any subnet or other data center you wanted to, and they would register with the workflow server, and certain steps could execute, certain kinds of operations could execute against those remote action services. And so there was a .NET version, there was a Java version, obviously, and we actually had a Perl version as well. That's how we got the Perl in there. But it was basically a SOAP API. Originally, we actually moved to REST. SOAP became more and more horrible. And it had sort of a reverse proxy topology, so you could deploy it inside a secure environment and it would only be popping up. So that was critical. And then we had originally we didn't have any kind of parallelism in the product, and that worked great. Probably would have worked great forever because you typically would just launch more flows in parallel. If you wanted to do something, we had a way for a step to invoke another execution of a workflow. But it just became cumbersome, and so we added actual split join and what we call group parallel operations within the workflow system. And so what do I mean by that? So split join is what you think basically at some point the step can execute multiple transitions in parallel. And that would invoke what we call, they're kind of like subflows, but they're in line within the flow. And these steps would execute in parallel and join at some point. And there were some parameters you could define in this, like don't exit until all of these flows have completed, or don't wait for them, just wait as long as the first one comes in, exit. So we had a lot of parameters you could configure on the parallelism. So that, and we had this nice visualization to show you this one way. The other kind, I don't have a visualization for it, was the group parallel, which really means, do this operation for every element in this collection of closure. So you can have, if you wanted to ping every host in the subnet, you could feed it a list of IP addresses and launch the ping op as a group parallel op and run all those pings in parallel. And again, there were some ways to configure that, like throttling how many you do at once. Again, not to wait until they're all done, or continue execution right away. So that was a pretty easy win for us to add it to the system without really changing our domain model in a significant way, to add the parallelism. When we did that, so when we added parallelism, all of a sudden, we had this problem where flows invoking subflows, and within parallel tracks would just expand the number of threads the system consumes. So we had to figure out a way to throttle the number of threads any given execution consumes. So we ended up implementing a custom thread pool that could do that.
Is this all done in one process with multiple threads, or did you try multiple processes?
You could launch multiple instances of our, so you could have as many workflow servers as you want, and there was an operation that can invoke another workflow. And so you could actually, before we had the parallelism, you would typically get nice balancing across those systems. But with the flow, there was a design to balance those threads across them, but we never really got to it. And it was pretty challenging because we had to, if you think about it, some of the state is intrinsically in the workflow and most of it is not. So if you're going to create an SSH connection to something, and then over several steps you could actually call into the SSH connection, it's pretty hard to balance that off into some other system unless you're using some VMware technology. So there was some state you couldn't really persist. So we ended up just, when the parallel threads happen, it's within one process. Now, there were some pretty interesting ways you could go and instrument into your workflow. Like, here's a checkpoint, right? This is a point where you could passivate the workflow. Like, you're going to pass it out to someone else. And you had to know as the author that, oh, my SSH connections are closed, or if I continue, I've got to recreate them. So you had to know what you were doing as an author. You could build these checkpoints into the system, and if a failure happened, it would resume that point, and they could balance over to another server. So, so this was the topology, had basically a collection of servers that were load balancing requests seen from web clients or other IT systems. You could automatically trigger workflow based on some alert happening. That would call into the same API to launch the workflow. There was also a scheduler, schedule flows. And then you had these RAS, remote action service, executing operations. Over time, most of the operations got built as RAS operations. And really just the execution logic was happening in the workflow server. And then we had this database we supported several, SQL Server, MySQL, for persisting in its execution history. So the domain model of our run, of our execution, we had a run object, which is the triggering of a workflow. And basically what it did is, our strategy was when a run happened, we'd snapshot, we'd do a deep copy of the workflow and associate that run. So even if you deleted your workflow or upgraded or everything, that run, the contract was, it was gonna begin and end with the definition of the workflow as it was defined when it ran. And so this is different than, you know, that wouldn't fly if these things were running for months. But for our system, these were short-lived things. So we snapshot the run, and we snapshot the workflow, and it was serialized with the run. We had a notion of a frame, so every flow would have a frame that it could run, and if it invoked a subflow, it would have its own frame, just like a regular stack. And then we had this notion of a pipeline, which I'll talk to a little bit later, but it was a way of capturing snippets of logic that a step would need to invoke. And again, I'll talk about it more later, but it's really the definition of how the workflow engine interprets the flow. Checkpoint, I mentioned that. A view is pretty cool. So if you think about one of these web browsers running a flow, they would basically see the same visualization execute a web browser. I'm trying to get a snapshot of the web UI, I couldn't find it. But this, so imagine this is like animated, like with a little robber that follows down the steps, and a panel on the right showing you the state of the workflow. Well, I've discovered this host, and and you can see the history of what it's done. So it's this really rich Ajax-style application that could show you that interactively what the workflow is doing. But we didn't want to. It was challenging to get all of that information down to the browser. You didn't really want to see every single event that was happening in the workflow. You kind of want to see snapshots of it over time. So we created this concept of a view, which is really sort of exactly that, a snapshot of the state of the workflow at any given point. And so these were created by the engine if you were connected to it interactively and sent down to the browser to display, to drive the animation. But you could dial up and dial down the resolution of that view. Right? So you could say that the view is created every what we call micro step, or microkernel step, which is really like think of it as a line in those pipeline operations. Operation pipeline. And so it was really cool for the debugger because you could instrument, you could turn traps on within the execution engine. Say before this input is bound, break and let me see what's going on. And so the combination of view and this kind of trap infrastructure makes it really easy to debug what's going on in your workflow. I'm sorry. Maybe this one, breaking sound. Light. Yeah, that's there we go. You guys are all frowning at me. I thought maybe it was me.
I'm not trying to hear you back here.
Right, yeah.
Can you start again from the beginning?
Okay, where was I? Yes, so we had views and traps, made it really cool and interactive for you to see what was going on in your workflow and diagnose as the author what was wrong with your workflow, and also manage the amount of traffic that was going down to the browser on the state what was going on. So this is the domain model of the run. So yeah, we've got runs. They basically had an API where it could execute steps and execute the operations within the step, and it would basically call that with a set of bindings that would satisfy all the inputs of that operation executed. So, you know, a run would create a frame for every flow it executed and had some map of state, key value pairs basically, that then other steps could refer to. They could push and pull data from the state. And there's the flow model is here. So this is interpreted to create the execution objects at runtime. And then we have this pipeline. So there's this, there was this kind of this API where when a run would encounter its step, it would, it would go and we'd call execute op on that binding. Inside of there, it would basically do this thing where we call it Git pipelines, but really it would take a step and say, well, what pipeline should I use? And it would use a bunch of information to do that, like the op, the kind of op it was. But more importantly, was this step a parallel step? Or was it a group parallel step? Or was it a regular step? Was it an exit step at the end of the flow, and so on? So we had these little snippets of code, this extensible pipeline class hierarchy, which is a real winner for us, because we could extend the execution engine without having to rewrite a bunch of stuff. All we had to do is go and build one of these little snippets and then register with the run, and we had some pretty cool IP around sort of identifying the kind of snippet that was relevant for this step. But basically what happened was it would go and kind of do this analysis, this sort of static analysis on the step, and come up with a set of pipelines, stitch them together, and then execute those as a group. And so these guys, all they were was, they could almost be like just static methods. They didn't really have, all the state was passed in. They were just little snippets of code that we stitched together, and we're able to add things like parallelism without having to rewrite a bunch of stuff by just adding those kind of pipelines. So that was like super critical for us to have this extensible run execution engine, because you're gonna always encounter more ways you're gonna want to enrich the environment. As you get into more requirements, or you want to go into different domains, that was really important for us. Okay, so that was I conclude. That was a great experience. It was a great acquisition by Opsware. When we initially started, we were in this IT problem resolution domain. Like, usually we'd say we're gonna automate the resolution of your problems, and Opsware really added more of provisioning. Their server automation product was really about provisioning, OS, patches, services on servers, and we were able to enhance that product by linking them up to the other IT systems. So before you go and provision this, OS on this, web server, you want to go and make sure there's a ticket created. You want to make sure it's out of the load balancing pool. There's a lot of just stuff you have to orchestrate. Maybe a person you need to have the approval from. So we could add all that capability to that product, and really added a whole other domain for us. And a lot of these features were driven by adding that different domain. I would like to think that was a pretty instrumental piece of the acquisition of Opsware and HP, where we even extended further the capability of the platform to deal with all the other HP portfolio products like storage automation, their CMDB infrastructure. So that I spent 2 years basically figuring out integrations for this product at HP with other products.
So you must have had a large library of operations that could be reused in different workflows.
Yeah, like I said, we had, I think, 10,000, maybe 15,000 out of the box operations.
And
But only like maybe 15, 20.
did you have to version the operations, because you don't want to change, you copy the workflow, but there's still referencing operations that might change.
Yeah, we had a support version, so the repository you could have multiple versions of an op. But yeah, there was maybe 25 atomic ops, right? That those 10,000 were created. So it's pretty simple bottom line. Okay, so how am I doing? 8:08. When am I supposed to go till?
About 8:30, 40.
Okay, good.
I got a
So I don't have
question.
that much more.
So, how does a user choose from 10,000 ops?
You need a workflow for that.
You need a very rich content management solution, right?
I mean, is
So-
it like a big pull-down list? What are we talking about here?
Yeah. So we didn't just throw ops in there. We had a notion of accelerators. So there was sort of domain areas within the content. If you're dealing with email, within there it could be Exchange, or it could be some other email system. So we had this sort of hierarchy of accelerator packs, and then domains, and then accelerator packs within that domain. And we had a content team that was aligned with that. So we would actually productize those. We'd say, here's the new content pack for, Oracle, and that would live in the database domain, and so there'd be an Oracle solution in there. We have some wizards. We didn't really ever get there in terms of help you create a flow. But we found that if we had the right kind of enablement around these accelerators, you could get started pretty quick. And then we had this really rich content repository, the search, right? So everything was keyed. All the content was keyed with keywords, or you could like search for like enter like sort of a description of your problem, and we'd show you results that were pretty good at listing some workflows that were relevant. And then within an accelerator pack, there would always be the basic operations, the out-of-the-box solutions, and most importantly, the example flows. And so you could say, I need to go and send an email when some system property in Oracle gets above some threshold. We had an example around how to get system properties in Excel. We had examples how to send email, and you can kind of easily stitch those together to create your solution.
But once you got beyond the accelerator pack and the starter stuff, somebody wanted to use any one of those thousands of ops you had, were they typing them in? Were they selecting them from
Yep.
some
They were selecting them, literally dragging them from here onto Canvas.
long, potentially long lists? How would they know? I mean, how would they pick? What was like the experience that somebody new to this stuff was going through to learn it? Were they going through one by one, reading some documentation, or how were they figuring out one op from the other?
Mostly there was example flows, which show you like here's a basic ops in like an email accelerator, and we try to be pretty comprehensive in terms of here's a flow that shows you how to do like check my quota, we go through and try to cover all the ops that are coming out. So a combination of documentation, example workflows, and rich search. And we had obviously training classes, but I think there is a barrier. There's certainly a barrier to entry to be an author. Certainly in a newer domain or more mature domain for us, but when we get the content to a certain level, it got pretty out of the box. Like there was a lot of commonality. We saw it that early on. We saw this a lot of commonality in the problems that IT was having. Like you could cover like 90% of the tickets with simple content, but then there was like the gnarly 10 to 20% that, you had to be basically a scripter to solve this problem. We weren't really going after that. I mean, we can enable that person. Like, there was a technical person that could come in and easily get deep in the product and solve that problem. Wasn't really our sweet spot.
So you didn't burn down the interface with the 80% that you weren't going to use as much. You focused on the 20% that most people do use. Is that kind of what you did?
I don't know if it's 80-20 in terms
But
of
whatever
actual
percentage,
content.
I mean, there are obviously a whole bunch that people weren't going to use day to day.
Yeah. I mean, if you're gonna like write a script to go and do a one-time thing, that was not our sweet spot. It was more like, I need to operationalize this. This is a known problem. We need to operationalize it. First, we need to triage it. We need to know, whenever this happens, I need to know these pieces of information before you send it to my tier 3. Right? That was our key piece. And then that tier 3 person, as he understood the problem and could come up with a repeatable solution, that person could codify the workflow, typically, to solve it. So we wanted to really let tiers of technical people get into the product, really super non-technical people, dragging and wiring, just lining some stuff up, but also super technical people to go into a scripting interface and codify a solution. And I think we did pretty well there.
Is there like a threshold where the complexity just became too much for the workflow?
Well, subflows. If you're doing a big thing and you want to put it in, you try to compartmentalize stuff and put it in. That's like there's some situations where it gets pretty hard to do that. So yeah, I mean there's like no silver bullet. I think for automation, you try to get to the sweet spot. And I was kind of surprised. Like we had all these ideas how you could like groups, like instead of subflows, like put everything in the same. Putting data on, showing data visually. We had all these great ideas on how we could make it, but we kind of got to a point where it really started taking off on its own. And when most of the content wasn't developed by us, we knew we had something special. So I think there's a certain level of complexity that you have to get over the hump in terms of producing, and then it kind of goes by itself.
So you mentioned storing the workflow definitions in this XML repository.
Yeah.
And so the actual workflow executions, how are those stored?
No, so yeah, like I said, when the run is created, it does a deep copy of
history database.
Yeah, it basically does a deep copy of the workflow when the run is created, so that that run is sort of an independent entity. It can exist, and the repository can go away, you know, go offline or whatever. It can be failed over to another server without needing a
So
repository.
only state and data is written into that
Yeah.
document.
That you can. I mean, some state, like I said, is not. You know, there might be an SSH connection you create. That's you have to be so there's a
Also
checkpoint.
persistent state.
Yeah, so there are certain checkpoints where it was passive and then can be filled over. But yeah, generally you need to do deep copy, like I said, so that we could guarantee the execution of the run. Okay, so shifting gears a little bit. I wanted to talk about some cool stuff we're doing at Apptio around data. It's a very different style of workflow where we're dealing with large sets of data. A lot of it's unstructured. I should step back and say what we do in Apptio first. So Apptio, we have a product suite around what we call TBM, Technology Business Management. What we do is we get a bunch of data from IT systems and let you build a cost model that models how costs should flow from like your GL data that we upload to how we should allocate that to, you know, your data centers, your people that work in those data centers, power for those data centers, up into the, you know, the IT resource towers, the servers, network storage, up into the services that are running on top of those, and even all the way up to the business units. So you can kind of build a cost model for IT. This is like huge for, you know, companies like you know, FedEx that have billions of dollars in IT spend and have very limited understanding of where that money's going, or what's the ROI in that money. So at Apptio we take data from a lot of different kinds of systems, you know, like I said, GL for sure, monitoring systems, asset management systems, CMDB, service catalogs, a lot of IT and financial data, and it's from a lot of different vendors, SAP, Oracle, HP, BMC, and so it's can be pretty dirty, especially ticketing data, where you have a lot of manually entered data, different names for the same thing, fat-fingered host names, so on. So a lot of dirty and somewhat unstructured data that we need to bring in and pull into our model. So we need to turn this, you know, data into information, typically I would say customers have you know, hundreds of megs of data they pull into the system for our big customers, but when we calculate that data, it grows like 2 orders of magnitude when we run it through our cost model. And certainly in the aggregate, we have hundreds of gigabytes of data, and we will, as we grow, get into terabytes, or hundreds of terabytes of data over time. So we wanted to solve this, we didn't really attack the cost modeling problem, more just the transformation problem and getting the data into a normalized form so we can put it into our cost engine. We wanted to create an ability that would be scale out and really flexible and extensible for our system over time. And we saw some pretty cool stuff emerging from a group at Stanford. Maybe I can click here. I don't know if you guys have ever seen Data Wrangler. It's a pretty cool interactive data transformation capability where you can sort of work with data. I just have some simple data and just click on a piece of this data, and it'll suggest some things I might want to do. Delete empty rows, that sounds good, and it'll actually create a step in basically a workflow to go and execute that. And so you can kind of interactively work with data and get it in the format you want, and it's capturing the history of what you're doing, so that when you're done, you're like, oh man, that's an executable workflow I can use repeatedly over time. And we like that. There's a lot of affinity with what we're trying to do for our authors when they use a product with what these guys at Stanford are doing. And so we wanted to kind of copy them, but not exactly, because this is not the greatest UI. It's not really using a scale out back end, so we wanted to really have the ability to use MapReduce to execute our workflows. We wanted a much more rich workflow repository, much more extensible. So we selected the stream processing approach and worked on building our own capability on top of that. And so we identified we wanted simple pipelines. There's not like branching or conditional logic that we really needed. It's really more, we wanted to do what the Wranglers doing, just like run a sequence of steps. What's it card now? Well, same thing, a lot of the same entities that I use for IConclude, I suggested, Eric Terrio's our lead on that project here with us. I suggested that Eric you might want to use some of those things, and he definitely ran with it. So there's still this notion of an operation. Each one of these capabilities is an operation. It has inputs, and the input, whereas we don't really have the same kinds of types. There's still a notion of types of those inputs, and this notion of cardinality. So you can have operations that work on one or more columns, like a group by or sort. We also found this Java project called Cascading, which is a pretty interesting project that has an API, sort of a higher level API on top of MapReduce, where you create these flows. And I'll talk about those in a little bit, but we identified that was something we wanted to do because Cascading has gives you an easier way to build. Well, I'm going to talk about it on this other slide. Let's talk about it now. So it's an API that's easier to develop these MapReduce tasks. It's like you don't have to understand all the gnarly bits of Hadoop, but it also has multiple execution styles, so it actually can run on Hadoop or in memory, and that's pretty cool because we want to have this interactive experience as well. Hadoop is not really an interactive technology. We want to be able to scale out for big jobs, but let you interactively work with the system to kind of build your workflow.
So it's the exact same code, or you have to, it just supports writing? Okay.
It's the same
Exactly.
code, just a different jar.
Okay, keep me honest. And the way Cascading works, it was pretty, we saw how we create these flows and steps and stuff, and they would easily map to the cascading constructs. So it was pretty similar, it's a basic workflow engine. Okay. Yeah, so for the interactive data, you wanted to support, when you're creating your pipeline, you're in your history, you want to be able to go back in time and see what the data looked like. That was important. We wanted to be able to select the rows, the columns, and react to that. That really more drove the UI, and not really the cascading capability, but the UI to help you create that was important for us. We wanted to contextually show you, based on your selection or your history of what you've done, these are the operations that are interesting for you, right, to give you a good fidelity and that suggest. So like when you select an empty row, it says, would you like to remove empty rows? And then we wanted to capture what you're doing in this flow that we create for you. So, in cascading, there's workflows and there's steps, but they don't execute sequentially. They sort of stream that data through. So data kind of flows through and is transformed from beginning to end. So this is like an example from their website. You're going to do a word count. You're going to like tokenize some data, and by that typically, well, in general, cascading works on the notion of tuples. So data will be defined in some form that your first step is typically you're going to convert that into a stream of tuples, like one for every row, and there will be a tuple entry for a column in that data. And that data will then be processed by different operations, and this scrub is going to maybe look for certain tokens that match some regex or something, and then once it's determined all of those, it's going to do a group by, and then count the ones that are in that, and then dump it into what they call a sink. So there's taps and sinks. Look at Eric because he knows a lot more about this than I do. And then steps in between. And you can have multiple taps and multiple sinks, and you can connect these together. And so we thought we could build these steps and flows that would be easy for us to capture the user interaction and all of our cool operations suggest in our meta language and then generate these cascading flows at execution time to be executed across in memory for interactive or Hadoop in one API. So actually they have a visualization. This is not like what it actually looks like. This is what it looks like. It's a lot more complicated. Yes?
Yeah, I was just wondering, is there any regression going on there between your taps and your loops?
Question.
Yeah, statistical analysis.
Oh, sure. Yeah, you can actually do, you can do interesting things like, what is it called? A tick. Is that right?
Yeah,
Really? That's not our name?
that's not right.
That's their name?
Yeah.
Okay, you can have things like ticks that are metrics that these things can produce, like, you know, independent of the data that's flowing through in the operations that it's performing on. You could report metrics like, hey, so many values that are greater than X, or, you know, every 5th time this gets executed, tick. And you could use that for diagnosing, you know, data, the kinds of data that's coming through, or maybe the performance of your workflow execution, all kinds of great stuff. Is that what you were asking?
Well, theoretically, you know, the thrust of Hadoop is to analyze the data of different formats and
Mhm.
put it, to make it meaningful. They use these statistical algorithms
Uh-huh.
where they, you know, they do, it's mostly regression, but all kinds of, you know, least squared fitting and things like that.
Oh, I see.
So
I mean, I guess I should say that this is not a general MapReduce framework. It's really a data processing framework. You can do those things. There's probably better ways to do it in other, you know, functional languages or whatnot. But if you really, this is, the high affinity here is really for, I got data, and I need to transform it into some other form. You know, right? And that's really what we were focused on. But certainly we do summarization, you know, sums, groups, average, distributions, and stuff like that.
So you mentioned no conditionals, but I mean, workflows can have conditionals.
Yeah.
So how would that be implemented?
Well, in our system, in Cascading, the conditionals are more like, there may be a fork, like maybe you might have a workflow that, you know, at some point, if something matches something, send it on a different, you could still do that, but it's not like if this then that, it's more, these things head that way, these things go that way, you know what I mean? So we didn't have the notion of a construct, you know, like the responses in my old workflow, and I conclude, weren't really relevant here. And we have steps, we have transitions, but there's no like parallel group. Like it's already parallel implicitly, and you know, no kind of looping and stuff like that.
So do you plan to use this like for like almost real-time processing, or just like batch processing? Or
Yeah.
Because you could imagine like if you can do these, keep these ongoing counts, you
Yeah.
have stuff like, oh, we're seeing you're having
Yeah.
the average response time that we're reading from the server
Yeah.
is like greater than so much, then trigger this action, which is like spin off more servers, or
Sure.
I don't know. I don't know if that would be suitable at all for.
Yeah, Storm is a pretty good framework for that. We don't have a real-time use case right now at Apptio. It's something, you know, for example, for us, I think that gets interesting if we're trying to do like real-time pricing in cloud services, like, you know, getting real-time feeds from Amazon and stuff, and kind of have as accurate as possible to the microsecond view of here's your options of where you could place this VM, that kind of thing, but we haven't really executed on that yet. So we're really more focused on like batch processing.
Yeah, so for real time, you wouldn't be necessarily using cascading.
I wouldn't say that. I think it could be used for real time too. But there are a lot of other options. Storm is one of them for doing real time stuff that we haven't really looked at. And it might be that if it's not cascading, it's still our flow framework, our flow language that we could then compile into something like Storm. Not sure.
Yeah, the concepts are very similar to the concepts of Storm. Storm, of course, is the emphasis on streaming data, yeah.
Yep. For sure. I don't think it, I mean, I think it could work for that. So, yeah, so this is there, so you can actually create a program in Cascading and generate a dot file, which is extremely hard to get a visualization of. But if you can, it would look something like that, and it's somewhat useful to see what's going on. So, all right, so I'm going to try, with Eric's help, to walk through an example of what you might do with Cascading. let's say that you have a file that's kind of capturing a bunch of people driving around the country, and you have a file that has a bunch of trip IDs, stop IDs within that trip, which really are like a state in the union, and some other data, like creation data that's modified. You have another file that says just stops, which is, you know, trip ID, a stop ID, and some ancillary data. And you want to create a, I'm not seeing the difference between these files, Eric.
Yeah, you're only supposed to talk about the
Yeah,
middle.
let's ignore that. So let's say we just have stop ID and trip ID, and we want to create a histogram of states that have, like this, states by stop. So there's one state that has 130 trips that visited it, right? So if we were to have this data and create a cascading flow that would do that, it would look something like this, where you create a tap, which is really going to say from this file, get tuples and send them downstream. So we create a tap on the stops per trip. A pipe, I think, is just a construct within the workflow that says formally tuples are going to flow through it. And then we have some operations on that. You know, so we're going to create a count field for every row in the file. We're going to drop all the tokens of every ID in that count, and then we're going to group by the trip ID. So now we get a count of all the stops by trip ID, right? So we'll get like this trip ID had 2 stops, this trip ID had 3 stops, and so on. And then we're going to rename that count to sum. The sum that was created is going to be renamed into states, and then we're going to add a new count that is going to be a count on that state, right? And we're going to group by the states, count, and sum. So you get kind of this sequence of operations against your stream, and that creates a workflow. There's some magic that happens in this flow connector guide that puts the source in sync on the front and the back. But it basically gets compiled into something that can execute either memory or across the. And so what we found was we could actually take our notion of the workflow without the fancy responses, transitions, but it has steps, transitions, and the bindings, which you know, there'll be things like it might be a column binding or a static value binding. There's another taxonomy of bindings that are relevant for this environment. And a toolbox, a collection of those atomic operations, and these kind of line up to the operations you get out of the box of cascading. So there's group, you know, rename, filter, plethora of operations you get in that toolbox. Each of them has some prescriptive inputs that they require. So load CSV, you can pass it to URI, which will probably be some HDFS URL. Rename is going to have you know, a from. We're going to rename this column. That's really should be called rename column. Or rename this column from, you know, count to sum, group by, and so on. So we could do all the validation, same kind of validation we did with include, and the same kind of binding capability, and take this metadata and generate a cascading flow at runtime to execute what we need to do. So you kind of get this same complex cascading thing that gets pretty complicated for someone to develop. They can work with our system and describe a set of these steps. We're basically going to load the CSV, I'm going to group by field ID, I'm going to rename some columns, group by the states, and then save it into result and get my output. So this is, you know, something that would enable a very simple Wrangler-like UI without having to know a lot of deep, gnarly Hadoop programming, right, or even cascading programming by working in our metadata language. And that is the same kind of pattern that I had at Untitled, where we took complex IT operations that only super advanced people knew and wrapped them in a metadata system that made it really easy to compose them for pretty non-technical people. Cascading is so far been super surprising to us in terms of, we already had a transformation capability at Apptio. It's pretty advanced in memory and columnar database we built ourselves and tuned like you wouldn't believe. Paul McLaughlin was here last year and talked about all his Java optimization capabilities. Probably one of the best out there. He spent years tuning that thing. When we transferred over to the Cascading system, the same kind of transformation we were doing for a big customer was done in quarter of the time that we had, what we were capable of doing in the legacy system. So we're really impressed with what we can do. The code is cleaner, it's simpler to understand for our users, and it scales out. It can scale out on MapReduce to terabytes of data, and also execute interactively in this kind of shell. So it's really an awesome fit for us. And the workflow engine just kind of pulls it all together. So I am out of content, but if anybody else have any workflow related questions or experience, yeah.
So in the workflow thing I worked in, they were using a custom domain language, and one of the developers convinced management to go to Groovy. And the thing that happened there is we lost our sandbox, and I was wondering how Rhino and JavaScript and Groovy related in the previous thing from a
You
sandbox.
lost your sandbox, meaning you couldn't guard against somebody doing something horrible to your workflow?
Doing something horrible with the server.
Oh, yeah. Well,
They could exit.
yeah, sure. I believe there are some, at least with Rhino, you can actually set up some privileged methods so it can't do certain things. And there are ways to hook it so you can actually see before it invokes things. But it's still, honestly, it's pretty hard to guard against that. And the way we kind of managed that was, there was a approval flow for content. So you could build into the content repository the ability to not let something go into production system unless every flow had passed through a review. So yeah, I mean, that's tough if you're gonna enable like Perl, like it's still like in our RAS ops, you're dropping .NET, .dll in there, or Perl script or whatever, and so, yeah, you could definitely get outside the sandbox. But the in-memory execution of Rhino, we got pretty good in terms of like, we'd only let you hit these classes. But yeah, you could still do something horrible. Anybody else like built a killer workflow system similar to this? I'd love to hear about it. I think, like I said, I think the most important, like after how many years I've been working on workflow, I think it's really the content, how you represent that to me is what's going to make it succeed. A lot of the other stuff comes down to table stakes in terms of your ability to execute in parallel and so on. But I think you can really differentiate. You end up differentiating on your ability to represent complex content in a really simpler way, so someone can actually understand what the hell you're doing. Okay, 8:37. Pretty good. All right, any other questions? I guess with that, thank you very much. We'll see you all next year. Thanks, guys.